Good morning, dear students. We are again back with the new topic lecture of CMOS design related to the layout and design rule. Now let us start the discussion regarding the design rules. First of all, in VLSI design, as processes become more and more complex, designer needs to understand the intricacies of fabrication process and interpret the relations between the different photo masks, which is really troublesome. Therefore, the set of layout rules, also called as the design rules, have been designed, or it has been defined that when you are going to design the circuits, you have to follow certain layout rules. The layout rule act as an interface or a communication link between the circuit designer and the process engineer during the manufacturing process. Design rule can be conservative or aggressive depending on whether yield or performance is desired. Now, what is the need of the design rule? The design rule are basically needed in order to check the following factors. The factors are the photoresist shrinkage, the tearing. Now, photoresist means that on the oxidation layer, we are providing a cream for the ionization of the oxide surface. If there is a change in the thickness of the photoresist, then the ionization area can be increased, which can lead to the loss of the power dissipation from the circuit. Or there is a tearing part, if some part of the N well or a tube well, N well or a P well tears out, then it is called as the tearing. So we need an exact rule to have a certain area, predefined certain area for designing of the designing of the photoresist area and for the removal of the etching. Then the second point, the second factor can be the variation in the material deposition. Material deposition means that if you are going to deposit the N-type material, if you are going to deposit the P-type material, that is called the material deposition. Even if you want to take out the interconnect in the form of aluminum metallization is done, or if you talk where you have to do the wiring section, so we need a specified defined area for designing of the metallic contacts. Now the temperature and oxide thickness can be another factors. Impurity, the concentration level of the impurity can be another factor. Then the variation across the wafer size. There can be variation across the wafer size also. These are the different factors which led to the need of the design rules. Then the design rules primarily addresses two issues. First of all, the geometrical reproduction of the features that can be reproduced by mask masking and lithographical process. And second is the interaction between the different layers. So from these points, it is clear that when you are using the design rules, the design rule will help you to interact between the different layers that are designed during the CMOS process or the bipolar process, or the hybrid technology process. Now, we will discuss about the different types of the design rules that are based on designing in industry. There are basically two types of the design rules majorly used for the designing of the CMOS circuit. First one is the Lambda based design rule, and the second one is the micron based design rule. Then the majorly where we see the industry standards, the Lambda based design rules are used. The Lambda based layout design rules were originally devised to simplify the industry standard. Micron based design rules allow scaling capability for the various processes. It must be emphasized, however, that most of the submicron CMOS process design rules do not lend themselves to straightforward linear scaling. The use of Lambda based design rules must therefore be handled with caution in submicron geometries. Now we will discuss about the major factor that is called the Lambda based design rule, because the industry is following this Lambda based design rule, and we are going to discuss about that Lambda. What do you mean by the Lambda? Lambda is the size of the minimum feature. Now whenever you are going to decide a width, for example, if you have to take the N well, so for certain N well you have a length and the width. The length and the width is measured in terms of the lambda. All the dimensions are specified in integer multiple of lambda. Specifying lambda particularizes the scalable rule. Parasitic are generally not specified in lambda units. Parasitic means the capacitance effect. The parasitic capacitance effect, what is generated due to the combination when you are having a p region and n region closer, then there is a parasitic effect generated that cannot be calculated using the lambda units. But these rules specify the geometry of the mask which will provide the reasonable yields. Now as you can see that we have seen the layer description and the representation. Now as for the lambda based, there are different convention used for the different type of the specified symbols. For example, if you are going to use the metal is used for the interconnection actually. So interconnection, for the metal interconnection, we are having the different types of the model M1, M2, M3, M4, M5. These are the different color coding scheme for the metal. For example, blue, light pink, yellow, then it is lightish green color. These are metals are used for these metals symbols are used for selecting the points for the metal contacts. Then we have next we can see that we have a well, where this symbol is used for the designing of the well when you are using the circuits. Then for the polysilicon, we have a polysilicon with a red structure. Then contacts and wires, there are different types of the symbols that can be used with these colors for the contact and wires. Then we are having the active areas and FETs. For example, N diffusion layer, we go with the green color. Then we have a P diffusion layer. Then we have NFET with this color. Then we have a PFET with again orange color. Then we are having the select where we have to use the N plus P plus regions. We are denoting it with this different layers. Now for as the picture denotes, this is given by the color coding is explained by the meat convey color coding layers, where we are describing the metal, the well, the polysilicon, the contact and the wires, and the active area of the FET. For example, N well, P well, which color you have to choose, and the last one is the selection area. Now basically this whole diagram explains, while designing a circuit through the CMOS technology, these are the points or the color combinations which are you are going to use for designing a CMOS. Now guidelines for use